Welcome to 5-Minute Math. This is Carrie Rhinehart. Today we're going to be looking at solving systems of equations by substitution. If you're following along in the book, it's from Algebra 1, Unit 4, Lesson 2. So in the last lesson, I talked about what systems were. We're trying to figure out where two lines intersect, and we looked at how to solve that graphically. But let's say that the two lines intersect in a point that is, it's pretty far, let's say 1820 is the ordered pair. Well, a lot of times you don't have that much space on a graph. Or let's say it intersects at a fraction. That's a little bit harder to kind of estimate when you're on a graph. So you can solve it algebraically two ways, and one of those ways is using substitution. Okay. When you use substitution, you need to get one of the equations, it doesn't matter which one, you need to get it so that one of the variables, x or y, again it doesn't matter which one, is by itself. So that then you can substitute what it's equal to into the other equation. So let's look at an example. Y equals 2x minus 1 and y equals negative 3x plus 4. This is the same problem I did on solving graphically. I'm going to show you how to do it with substitution now, and we will end up with the same answer. What's nice here is that both of them, y is already by itself. Okay? So if y is already by itself, it sets itself up for substitution. So here we see that y equals 2x minus 1. So in the other equation, wherever I see y, I can plug that 2x minus 1 in. So I'm going to go ahead and do that. For that y right here, I'm rewriting it with 2x minus 1. Equals, we've got negative 3x plus 4 on the other side. So again, we're just rewriting this equation, but we replace this y with the 2x minus 1. And now we need to solve this equation for x. So I can drop off the parentheses here. It's good to start with those in case you need to distribute, but we don't need to here. Now I'm going to get my x's together. I'm going to add 3x to both sides. So those cancel. 2x plus 3x is 5x. Bring down the minus 1 equals 4. Now I'm going to add 1 to both sides. So we get 5x equals 5. And then the last step to solve for x would be to divide by 5. We end up with x equals 1. We are not done yet, though. We want to know where these two lines intersect, so we need an ordered pair. So what I need to do is I need to go back to either one of these equations, it does not matter which one, and plug in 1 for x. I'm going to use this first one, y equals 2x minus 1. Well, x equals 1. You can see that here, so I'm going to plug that in. Y equals 2 times 1 minus 1. That gives me y equals 2 minus 1, which gives me y equals 1. So we end up with x equals 1 and y equals 1, so our ordered pair is 1, 1. And this is a consistent system because you end up with an ordered pair. They cross at the ordered pair 1, 1. Okay. I want to look at one more example. Okay. All right, so let's say we have the equations, 3x plus y equals 8, and 2y equals negative 6x minus 4. Well, in these, neither x nor y is by itself in either equation, but it would be easy to get x or y by itself in either one, so just pick one. I'm going to go with this one right here. I want to get y by itself. I feel like that would be the easiest by subtracting 3x from both sides. So I end up with y equals negative 3x plus 8. So now that y is by itself, in the other equation where I see y, I can just replace it with this negative 3x plus 8. So I'm going to get 2, and then parentheses, and negative 3x plus 8. Again, I'm replacing the y with that. Equals negative 6x minus 4. And now I just need to simplify and solve for x. So I'm going to distribute here. I get negative 6x plus 16 equals negative 6x minus 4. And now I'm going to get my x's together, so I'm going to add 6x to get rid of it over here. But if you notice in this case, both of these x's cancel out, and I end up with an equation 16 equals -4. If your variable cancels out and you're left with an equation like this with just two values, two things could happen. This is either inconsistent or it's dependent. Since this is not true, 16 does not equal -4, this would be inconsistent, which means there is no solution. These are parallel lines, they never cross. But let's say that the variables canceled out and you got a true statement. Let's say it said 16 equals 16. In that case, it would be dependent, which means they're the same line and you'd have infinite solutions. All right, I hope you guys have a great day.